Hello everyone, today we're going to look at rare events, the sample, decision, and conclusion. So for the rare events, you will assume the null hypothesis is true and then gather data and analyze it. If the outcome would be very unlikely to occur under your assumption, then you conclude that the null hypothesis is probably incorrect and you reject the null hypothesis. We will define very unlikely later on. Example. We take a sample of size n and find our point estimate x bar. Based on this sample, we calculate the p-value. The p-value is the probability that, assuming h0 is true, the results from another randomly selected sample will be as extreme or more extreme as the result obtained from the first sample. What we mean by as extreme or more extreme really depends on how we state the alternative hypothesis. But we'll talk more about that when we do an actual example. If this p-value is large, we should not reject the null hypothesis because then these extreme results are fairly likely. And if p is very small, we reject h0. The extreme results are very rare, and again, if it's very rare, if it's very unlikely that they occurred, then that's because h0 probably isn't true. For example, a normal distribution has sigma equals 1. We want to verify a claim that the mean is greater than 12. A sample of 49 is taken, with x bar being 12.5. So we want to determine if this sample with x bar being 12.5 is a fluke or is it actually not because the mean is greater than 12. So we look at our null hypothesis and our alternative hypothesis. So we want to verify the claim that the mean is greater than 12. So greater than 12 has to be the alternative hypothesis because there's no equal sign. And then the opposite of that is less than or equal to 12, which must be the null hypothesis. So our p-value is the probability that x is greater than or equal to 12.5. So the extreme or more extreme has to do with the fact that mu is greater than 12. So I want greater than, put that back. We want greater than or equal to that x bar that we had, the 12.5. So our p-value is always in terms of x bar, the sample mean, not anything to do with the null or alternative hypothesis. So it's the x bar is 12.5 that has to do with our p-value. We also have to remember that this is from a sample, so sigma isn't 1, sigma is 1 over the square root of n. So remember, we're using the central limit theorem here because we have a sample. So when finding this p-value, this probability, we need to remember that sigma is going to be 1 over 7 in this case. We'll also use Excel. Right, we know how to use Excel for the normal curve. So if you want to, you can pause the video, take out Excel, and try this on your own and make sure you're getting the same value. So if we do it, we get 0.000233. Under almost any circumstance, this is considered very small. Because of that, again, we say that it's very unlikely that the mean is actually less than or equal to 12. And remember that in the normal curve that we're using, we are assuming the null hypothesis is true, so we're using mu is equal to 12. Whenever we're doing the p-value, we assume equality in the normal the mean for the null hypothesis. Okay, so we're using that mu is 12, sigma is 1 over the square root of n, and then the number that's in question is again coming from the sample mean. Okay, so again, p-value 0.000233, definitely very small. That means that it's probably not true that mu is 12. So we are going to reject h0 in favor of the alternative, which means that we're confident that mu is in fact greater than 12. So let's see about decision and conclusion. How do we decide what p-value is small enough? So it said the previous example, p was very, very small. So that, again, almost everyone will consider that to be small enough. But what if it's a little bigger than that? How big is too big? What we do is we compare p-value to alpha, which is called the significance level. And remember, alpha was the probability of a type 1 error. Sometimes it's given to you, other times it's not, and you have to make a decision. You want to decide this before you look at any other piece of information. So before you look at x bar or n or anything else, you need to decide on your alpha if it's not given to you. Typically, we use 0.05 or 5%. If alpha is bigger than the p-value, then we reject h0 in favor of ha. We say p is too small, it's smaller than our significance level, so we reject h0. If alpha is less than or equal to the p-value, we do not reject h0. Now remember, this is not the same as accepting h0. We don't ever prove h0. Excuse me. The sample has failed to provide sufficient evidence to cast doubt on h0. Okay. So again, it's either reject h0 or do not reject h0, but it's never we've proven h0. Okay, so we don't do that. Reject h0, do not reject h0. Those are the only options. Remember, if we reject h0, it's in favor of the alternative hypothesis. After deciding on whether to reject or fail to reject h0, we must answer the question in terms of the claim. And remember, the claim can be the null hypothesis or it can be the alternative hypothesis. So once you've decided whether or not you're rejecting or failing to reject the null hypothesis, you then translate that back to the claim. For example, Chips Ahoy claims that there are at least 1,000 chocolate chips in every bag of their cookies. Here are the results of one hypothesis test. State a conclusion for this test. So we have our null hypothesis is that mu is greater than or equal to 1,000. HA is that mu is less than 1,000. Alpha is 0.01. P is 0.025. So we're going to compare alpha and p. Alpha is less than or equal to the p-value. That means we fail to reject h0. Okay? And then since h0 is the claim, remember the claim is that there are at least 1,000 chocolate chips, that's the null hypothesis. So since h0 is the claim, we are failing to reject the claim. So we'd have something like, we do not have sufficient evidence to disprove the claim that there are at least 1,000 chocolate chips in every bag. Or something like, we are fairly confident that there are at least 1,000 chips in every bag. Okay. So let's try another one. It has been said that people spend, on average, 5 hours per day with digital media. Test this claim with a 15% significance level. We found the p-value to be 0.0455. So h0 is mu equals 5, which again is the claim because they're saying that they spend 5 hours per day. So the claim is the null hypothesis again. The alternative hypothesis is that mu is not 5. Again, I'm not saying what it is, it's just not 5. Alpha is 0.15, and then the p-value is 0.0455. Alpha is greater than the p-value, so we reject h0, which again is the claim. So we have sufficient evidence to reject the claim. People do not spend, on average, 5 hours per day with digital media. And again, I'm not saying they spend more, I'm not saying they spend less, I'm just saying it's not 5. Right? We want to see if it takes fewer than 45 minutes to teach a lesson plan on average. If alpha is 0.10 and the p-value is 0.03, make a statement about the claim. So again, the claim is we want to see if it takes fewer than 45 minutes, so that's mu is less than 45. So because there's no equal sign, that must be the alternative hypothesis. And again, we're going to use the true complement of that and say that the null hypothesis is mu is greater than or equal to 45. So this time, the claim is the alternative hypothesis. Alpha is bigger than the p-value, so we reject H naught, which again in this case is not the claim. So we reject H naught, which means we're in favor of HA, which is the claim, so we are in favor of the claim. So our conclusion would be something like, we have sufficient evidence to accept the claim that it takes fewer than 45 minutes to teach a lesson plan on average. So again, once you've decided to reject or fail to reject the null hypothesis, we then translate that back to the original question, and reformulate it into the terms of the claim. Do we accept the claim? Do we not accept the claim? And again, it's very important that you know if the claim is the null hypothesis or if the claim is the alternative hypothesis. Okay, so make sure you've read through the book and let me know if you have any questions. Thanks.